Welcome to the wonderful world of prototyping where you fix one thing and break another. So we solved the friction problem because this thing spins like a charm now. I had to use open bearings, as you can see in there, hopefully, because if they were shielded or fully enclosed, there was too much friction. Maybe not too much friction to work. You could always get a larger rotary actuator, but with my current setup, too much. So I fixed that problem. But then look in there, you can just see the bottom of the bearing opening, and these needles are small and they would just fit in there. However, there is one thing that I realized is that solving this problem might fix another. So the needles themselves, this is just aluminum because this is 1/2 inch and this would weigh a ton if I used steel. So I used aluminum, but the bearings, the needles have a sharp point and they tend to drag a little bit on this aluminum when they go down, sometimes sticking, turning up a burr because they're that sharp. So I was gonna cover these with something hard to solve that problem anyways. And so I thought, hey, if I just put a piece of spring steel that has been hardened or shim stock that has been hardened on the whole side here, I can cover that position where that space where the needles could get into the bearings, and at the same time I'd provide a hard surface where the needles hopefully wouldn't stick. So that's where we're going to go next. I got some shim stock here and I want to use something moderately thick, like maybe 10-12 thousandths at least, but then I got to figure out how to cut that. Well, we have a tool that I've shown in the past, which is the shear here, and it's not very convenient to use on the ground, but I also made this tool for a universal mount on top of my bandsaw. So let me install that real quick and we'll see if we can cut this material roughly to size. So this guy mounts on my bandsaw top, and there's a second hole here, and that hole is for a pin so that this thing doesn't rotate, so it just tightens up nicely. So there's one on each side, and then you just snug it down and we're good to go. And I left the screws in last time to mount other tools up here. So we're gonna get the shear up here and prep to trim this guy, trim some shim stock. Now the shim stock's hardened, so hopefully it won't damage the shear too much. I've got a little bit of concern there. I just realized this now, this could also be used as an auxiliary fence when you're cutting something if you want to just slide it back and forth. I didn't even think of that. That'll be a future use potentially. So I'm going to take advantage of the pseudo square factory edges. They're actually not perfectly square at all, but I'm going to keep those. But I did draw some lines on here so that I could get this somewhat accurate. This thing cuts this stuff like butter. Using it on the ground as I usually do is not the ideal solution. This is working out so much better. Normally things twist in your hand while you're trying to cut them, but not when I'm doing this with this solution. I might even be able to cut these to size on here. It's cutting so nicely. I'll have to see if I can actually scribe lines that accurately on this. So here's my two rough cut pieces. All right, so I got these cut down to size. I did actually, the final trimming, I thought I'd recorded it, but I didn't. But anyways, cut some pieces off. Here's my finger for reference. I was able to shave off really thin sections of that 12 thousandths thick material on that shear. I did not think it would have such good control, but it was pretty fantastic. That's amazing. And just skimmed the edge, which this thing, when I originally got it, I adjusted this blade so that this gap here was very negligible, and I trimmed off just tiny amounts of material, which is pretty fantastic. So the next step is to drill the 4 holes for the mounting of those 2 V plates so that this gets stuck behind them. I'm also going to take it off over to the Scotch-Brite wheel, and I'm going to remove this burr on the edge here so that these are nice and sharp. Drilling these might be a bit of a challenge all by itself. I had long thought about machining these on the mill, but the only solutions were something like vacuum plate, which I don't think will hold tight enough, or the other solution would be to super glue it to like an aluminum plate and just machine around it. That would work, but then getting it off is a little challenging. So we're going to try and drill the holes next. All right, so this looked like a job for the mini pallet, and we've got both of them stacked up on top of each other with the squarest two sides up against the pins. And I've got a carbide bit here. It's a number 9, so it's a little oversized, which will give me some room to move things around in case it's rubbing, so that's good. And we've just got them both clamped down to the mini pallet. These pins were drilled and reamed to be right on position, and they're a piston fit in there, so I think that's a good sign that they're pretty accurate. And since this is such thin material, it's touching at the base, which is the most accurate point, so even if they weren't dead perpendicular, which I think they're relatively so, they'd still be very good accuracy wise. The only thing I had to worry about is, since there's a slight difference in size, since I cut these independently just on a shear, there's like 10 or 15 thousandths difference between them. I just made sure that I pushed one all the way up and then slid the other one over to make sure it's a good fit. And the way I've set my drawing up, I don't know if you can read that here, but we're going to take our datum off the side here, but then we're going to find the center line, and everything's going to be based on the center line. So once we find the center line in this edge, which is going to be the bottom, that goes where the roller is, that's the important part, and we're just going to follow that the whole route. All right, so I've got my sheets set up in here. All I'm going to do is drill 4 holes in them for the V's to line up. And the only important part is that the bottom center ends up just above the rotary shaft. So this should be fairly straightforward. I thought about putting a piece of sacrificial aluminum under here. That could be handy. I don't know that I have one, but that would be really handy so that I didn't drill into my mini pallet. I was just about to find my zeros, and I was thinking I really would like to raise these parts up a little bit. So I decided to put a sacrificial plate underneath it. And I've just got this aluminum just sitting here. It's not touching the pins at all because it doesn't need to. So I'm sliding this first sheet over, making sure it touches these pins and these pins. This pin, and actually, well, that'll work. And then this one, same thing, pushed over. Make sure it's touching the pins. And we're just going to tighten these guys up, making sure that they're making good contact. I decided to add one on the side over here. That looks good. And we are making good contact. So I just need to find my zeros, which will be easier now that it's not flush with the plate anyways. Then my midline point, rather than go to both sides and divide by 2, we're just going to measure over 2.114, and we'll call that our new 0 point. That should be dead center. And now I just need to drill my 4 holes, and to do that, I've got a carbide drill bit because this stuff's pretty hard. I don't know if this specific stuff is the super hardened stuff, but it's definitely not easy to drill. I think this is the spring steel stuff, but I'm not 100% certain. In any case, we're going to use the carbide drill bit just in case. Again, we're drilling. I'm using the hand wheel instead of the arm on the mill, because this you have to keep repositioning, and this is continuous. It's pretty fantastic. Highly recommend these. By the way, these are oversized holes. By the way, when I call this out for you, I'm also calling it out for myself to double check, because I'm checking the print as I go. And these again are oversized holes, which will give me a little latitude. This carbide drill bit's really cutting through it like butter. All right, that's it. So we're going to test fit this. If this thing slops around too much, they're reasonably flat. They came off a very large diameter roll. If these things slop around too much, I found some of the same stock on McMaster car that has an acrylic adhesive back. And then what I'm going to have to do is I'm going to have to machine the 2 plates. I'm going to have to remove some material. So after I get these guys in there and make sure they fit, I have to remove a little bit of material off the 2 sloping plates on either side to compensate for this extra thickness. All right, so here are the 2/4 inch pieces of material. They did flex a little bit, so I've got them held together with some quick clamps here. And I need to take off the same amount of material as the thickness of off each side as the thickness of one of the two pieces of shim stock, which are 12 thousandths thick, actually 11.8 measured. So we're just going to take off 11.4, and then we're going to flip this over, take the same amount off the other side, and we should be good. After this, we can assemble and test. Be nice if I could sign off one problem here. Well, I already did. The bearings fixed one problem, but got several more to deal with. This should deal with the sharp pins digging into the aluminum, as well as the sharp pin, preventing the sharp pins from getting into the bearings that are open. All right, so let's assemble this guy. It's going to be a little bit challenging. So this goes on one side, and you notice that it is, since I over-drilled the oversized holes, it actually can fit down below. And even with that shim in there, it could actually, I could have made it deeper and it would have been fine. That's interesting to note. I could have gone all the way to where I was just about to touch the bearing. But in any case, this will be fine, I think. The second side is going to be a little more challenging. Now I did order some, you notice the flex here? I'm going to pull the flex flat, but also these plates are going to push on it, and they should push it flat, so I'm counting on that. But if they don't, I ordered some shim stock, as I mentioned earlier, that has adhesive on it from McMaster Carr. Here it is, stainless steel shim, 12 thousandths thick. It's actually 10 thousandths thick with 2 thousandths worth of adhesive on it. Here it is. This is the adhesive, this is the covering over the adhesive back. So if I need to, I can make these again and use this guy. This is definitely hardened steel, HRC about 45. But we're going to see if we can do without. Yeah, I think this is going to hold it nice and flat. The beauty is this surface here is now hardened steel, and that'll prevent it, hopefully, from having the needles stick, which they were when I tested it out. One of the many problems I had right off the bat that I didn't count on appropriately. All right, we have success. So we've got hardened edges on the sides. I need to file this guy just a little bit because it's sticking up just a tiny bit. Next, I think is get the vibrator and hook it on this back plate, which is this low voltage motor. And it's going to have, and I'm going to take this plastic gear off and put an eccentric or an off-center piece of steel on it. I don't know how much weight I'm going to put. I guess I'll try various, and we're just going to bolt this guy here somehow to the back of this to cause this to vibrate, which will hopefully cause those needles to settle. The problem is those needles are extremely light, and so they don't want to settle just by gravity. There's enough friction to prevent them from doing that. So we're going to try and solve that problem. And then we can hook the gears up and continue from there.